Here we go with another new topic, that is Lagrange's mean value theorem. In this theorem, you have two conditions. First one condition, the function should be satisfied as a continuous, and the second condition is it should be a differentiable. Let f of x be a function in the interval a comma b such that f of x is continuous on closed interval a comma b and f of x is differentiable on open interval a comma b. Then there exists a point C which belongs to the interval a comma b such that f dash of c is equals to f of b minus f of a by b minus a. So first condition, it satisfies as a continuous, and second condition as a differentiable. Then there exists a point that is C, and that lies somewhere in between the interval of a and b. Then the differentiation of the C with the function f dash of c is equals to f of b minus f of a by b minus a. Let's see the geometrical interpretation of Lagrange's mean value theorem. It states that geometrically, Lagrange's mean value theorem states that if the curve y is equals to f of x is continuous at points a and b and has a tangent at every point between a and b, then there exists at least one point C on the curve where the tangent is parallel to the chord AB. So it's saying that there are the 2 points A and B, and the C lies somewhere in between those 2 points, and when we draw the tangent at the point C, the tangent is parallel to the chord AB. So if you see the graphs here, the first graph, it's a curve is like this, and here the points are A and B. The coordinates of A is a comma f of a, and the coordinates of b is b comma f of b. When we plot it to the x-axis, this will be the a and this will be the f of a, and for the b, on x-axis this is a b, and on y-axis here somewhere it will be of f of b. Then this is a point if you take as C, and we are drawing a tangent at a C, and this tangent is nothing but this f dash of C. F dash of C nothing but it's a slope of the tangent, and we know that slope of two parallel lines is equal, and the coordinates of C is C comma f of C, and when we plot it to the x-axis, the point will be C here, and it's lying between the points A and B. And similarly, if you see the second graph, these two are the endpoints A and B, and the coordinates of A is A comma f of A, and coordinates of B is B comma f of B, and this is a point C, and this is a curve f of x, and here is also the curve f of x. And when we plot it to the x-axis, this will be the A and it will be the B, and at C on x-axis it lies between A and B, and this is a tangent at point C, and this tangent is parallel to the chord AB. This is the chord AB, and these two lines are parallel. We are finding out the derivative of C, nothing but we are finding out the slope of this tangent, and the curve is f of x. Here also the same, this is the chord AB and the tangent is parallel to the chord AB, and the slopes of these two are equal because the slopes of two parallel lines are equal. So if you see here, for example, if you take a line and there are 2 points A and B, and the coordinates of A are x1 comma y1, and the coordinates of B are x2 comma y2. We are finding out the slope of these 2 points. So the slope of AB is, we write it as y2 minus y1 by x2 minus x1. So in a similar way, for example, if you take the coordinates of A as a comma f of A and b comma f of b for the point B, we are finding out the slope of AB. Nothing but this is a this is a x coordinate and this is a y coordinate, and here also this is a x coordinate and the y coordinate of the second point. So by this method, if you see here, f of b minus f of a divided by b minus a. So we know this, and slope of AB. So here the tangent nothing but we are derivating this function f dash of c. It means we are finding out the slope of this tangent, and the chord AB as a slope of f of b minus f of a by b minus a. So these two lines are parallel, then the slopes are equal. So slope of this tangent, that is f dash of c, is equals to slope of these two points, that is f of b minus f of a by b minus a. So we got the point, that is f dash of c is equals to f of b minus f of a by b minus a. Let's solve few problems on this theorem. Here we go with first problem on Lagrange's mean value theorem. Verify Lagrange's mean value theorem for the function f of x is equals to x cube minus x square minus 5x plus 3 in the interval 0, 4. The function f of x is x cube minus x square minus 5x plus 3, and we know that it's a polynomial function of cubic. And the first condition, it has to satisfy as a continuous function. Then it is continuous function since every polynomial is continuous. So we know the reason also. Therefore f of x is continuous in the interval 0 to 4. And we have to check for the differentiable also. Then f dash of x is equals to differentiation of the function x cube minus x square minus 5x plus 3. So f dash of x is equals to x cube differentiation with respect to x is 3x square minus x square with respect to x is 2x, and then minus 5x differentiation with respect to x is minus 5, and constant differentiation is 0. So 3x square minus 2x minus 5 is the f dash of x, and this is not equals to infinity for all x belongs to the open interval 0 to 4. So here the whatever the values you substitute in between 0 to 4 as 0 or 1 or 2 or 3, whatever the values you substitute here, you will not get any infinite value. So we get a finite value. Therefore f dash of x is exist, hence we get a finite value in the open interval 0 to 4. Therefore f of x is differentiable in open interval 0 to 4. And by Lagrange's mean value theorem, we have a condition, that is c belongs to the point a comma b. It means the point c lies in between a and b, and such that f dash of c is equals to f of b minus f of a by b minus a. So here we have to take the values of, we have to find out f dash of c here, and that is f of b minus f of a by b minus a. When we compare a comma b interval with 0, 4, a value is 0 and b value is 4. So a is equals to 0 and b is equals to 4. So here we have to find out f of b. F of b nothing but f of 4, and f of a nothing but f of 0. So f of a is equals to f of 0. Then substitute 0 in the function f of x. In the function f of x, substitute 0, you get it as 0 of whole cube minus 0 square minus 5 into 0 plus 3, and you get it as 3. So f of 0 value is 3. And similarly f of b is nothing but f of 4, that is 4 cube minus 4 square minus 5 into 4 plus 3, that equals to 64 minus 16 minus 20 plus 3 is equals to 31. Therefore f of 4 value is 31. And a of 0 is equal, a is equals to 0 and b is equals to 4. So we got the 4 values here. Then substitute in this formula, that is f dash of c is equals to f of b. F of b is 31, that is f of 4. F of 4 minus f of 0 by 4 minus 0, and that equals to 31, and f of 0 is 3 by 4. 4 minus 0 is 4. And 31 minus 3 is 28, divided by 4 is equals to 7. Therefore f dash of c you got it as 7. But from equation 1, from this equation 1, we have f dash of x is 3x square minus 2x minus 5. But here f dash of c, nothing but you have to substitute c in the place of x. Then you get it as 3c square minus 2c minus 5, and that equals to 7. So here 3c square minus 2c minus 5, and send this 7 to the left hand side, you get it as minus 7, and that equals to 0. So from here 3c square minus 2c minus 5 minus 7 is minus 12, and this is equals to 0. So here we have to find out the roots of that equation, and that equation was 3c square minus 2c minus 12 is equals to 0. So for that we are using the formula minus b plus or minus root b square minus 4ac by 2a. From this equation a is 3 and b is minus 2 and c is minus 12. We have the values here. So the substitute here, minus b, that is minus of b is minus 2 plus or minus root b square minus 2 whole square minus 4ac, that is minus 4 into 3 into minus 12 divided by 2 into a, that is 2 into 3. And here minus of minus 2 is plus 2 plus or minus under the root of minus 2 whole square is 4, and here 4 into 3 into 12, that is 144, and minus into minus is plus, and that equals to 2 plus or minus root 148 can be written as 2 into root 37, and that divided by 6 equals to, from this numerator you are taking 2 as common, then we get it as 2 of 1 plus or minus under the root of 37 by 6. Then 2 ones are 2 threes are, and that equals to 1 plus or minus root 37 by 3. So from here we get c is equals to 1 plus root 37 by 3, and that equals to, the value of this is equals to 2.36. And the next c is equals to 1 minus root 37 by 3, and that equals to minus 1.69. So we have the two values here for the c, and therefore c is equals to 2.36, and that belongs to interval 0 to 4. So in interval 0 to 4 we have only positive numbers, but for c we got a value as minus 1.69. So this will not come under the consideration of the point. So we have to take the value of c as 2.36, as the interval is only for the positive numbers. So hence LMVT, that is Lagrange's mean value theorem, is verified. Here we go with second problem, that is verify Lagrange's mean value theorem for the function f of x is equals to x of x minus 2 into x minus 3 in the closed interval 0 to 4. The function is x of x minus 2 into x minus 3, and it is a polynomial function. So when we simplify it, we get x of x minus 2 into x minus 3 is x square minus 3x minus 2x plus 6, and that equals to x of x square minus 3x minus 2x is minus 5x and plus 6 is equals to, multiply x with all these terms, you get x cube minus 5x square plus 6x. So we know that it is a polynomial function, and we know that every polynomial is continuous. So it is a continuous function since f of x is continuous in the closed interval 0 to 4. And for differentiable, derivate the function this, that is f dash of x is equals to d by dx of x cube minus 5x square plus 6x, and f dash of x is equals to x cube with respect to x is 3x square, and minus 5x square differentiation with respect to x is minus 10x, and differentiation of 6x with respect to 6 is 6. So 3x square minus 10x plus 6 is a f dash of x, and this is not equals to infinity for all x belongs to 0 to 4. Open interval 0 to 4. In between the values, whatever the values we consider in between them, then this value will not be infinite. So we'll always get a finite value, and that therefore f dash of x is exist, and since we get a finite value in the open interval 0 to 4, therefore f of x is differentiable in open interval 0 to 4. So the two conditions of the Lagrange's mean value theorem are satisfied. Then by Lagrange's mean value theorem we have, there exists a point C such that it belongs to open interval a comma b. It means the point C lies in between a and b, and derivative of c, that is f dash of c, is equals to f of b minus f of a by b minus a. Then f dash of c we have to find out. For that we need f of a, f of b, and b value and a value. So when we compare this interval a comma b with 0 and 4, a is equals to 0 and b is equals to 4. So f of a, that nothing but f of 0 is equals to 3 into 0 square minus 10 into 0 plus 6 is equals to 0. Then f of 0 is 6. Then similarly you have to find out f of b, that is f of 4, and that equals to 3 of 4 square minus 10 into 4 plus 6. That equals to 48 minus 40 plus 6 is equals to 14. Therefore f of b value is 14. And from here we know a is equals to 0 and b is equals to 4. Then here f dash of c is equals to f of b, that is f of 4, and f of a, that is f of 0, f of 4 minus f of 0 by 4 minus 0, and that equals to 14 minus 6 by 4 minus 0 is 4, and that equals to 8 by 4, that is 2. Therefore f dash of c value is 2. We know that f dash of c is derivative of that f dash of x. So f dash of x, we got it as 3x square minus 10x plus 6. So in the place of seg x, when we substitute c, we get 3c square minus 10c plus 6, and that equals to 2. We got it from equation 1. And then here 3c square minus 10c plus 6, and when you send 2 to the left hand side, it becomes minus 2, and this is equals to 0. So 3c square minus 10c, 6 minus 2 is 4, is equals to 0. So we have to find out the values for c. As it is a quadratic, in the quadratic form, we are applying a formula, that is minus b plus or minus root b square minus 4ac by 2a. So when we compare this equation, we get the values of a, b, c as a is equals to coefficient of c square 3, and b is minus 10, and c is constant 4. So substitute the values of here, we get minus of minus 10 plus or minus under the root of minus 10 whole square minus 4 into 3 into 4 and divided by 2 into 3, and that equals to minus into minus 10 is plus 10 plus or minus root 10 square is 100 minus 4 into 4 into 3 is 48 and divided by 6, and that equals to 10 plus or minus 100 minus 48 is 52 divided by 6, and that equals to 10 plus or minus root 52 can also be written as 2 root 13 by 6, and that equals to, take 2 common from the numerator, we get it as 2 of 5 plus or minus root 13 by 6, and that equals to 2 3s are 6, and in the denominator left over is 3. So 5 plus or minus root 13 by 3. So for c, we have the two values. One is 5 plus root 13 by 3, and another one is 5 minus root 13 by 3. So c is equals to 5 plus root 13 by 3, value is 2.86, and then c 5 minus root 13 by 3 value is 0.46. So both are the positive values, and the interval is 0 to 4. Therefore these 2 points lies in between 0 to 4. Therefore c is equals to 2.86 comma 0.46 belongs to the interval 0 to 4. Hence LMVT is verified. Third question we have, show that for any value of x greater than 0, the condition is 1 plus x is less than e power x less than 1 plus x into e power x. We had to prove this condition, and the interval we have to take from this x is greater than 0. So let f of x is equals to e power x in the interval 0 to 4. As we know that a given condition is x greater than 0, it means 0 is less than the value of x. So the interval we can take from 0 to x, and then here the function we are taking it as x, e power x. So we have to prove this condition, that is 1 plus x less than e power x less than 1 plus x into e power x. So we know that e power x exponential is always continuous. So the f of x is continuous in the interval 0 to x. And then derivative, f dash of x is equals to derivative of e power x, and derivative of e power x is e power x, and this is not equals to infinity for any value of x belongs to open interval 0 to x. So whatever the values you take here, you will not get any infinite value. Even if you take 0 also, e power 0 becomes 1. So we will get a finite value. Therefore f dash of x is exists in open interval 0 to x. Therefore f of x is differentiable. Then by Lagrange's mean value theorem, there exists a point C such that it belongs to the open interval a and b, and such that f dash of c is equals to f of b minus f of a by b minus a. So we have this formula f dash of c, and then here when we compare this interval a comma b with 0 to x, a is 0 and b is x. So in order to find f of b, f of a, b and a, we have to substitute the values of a and b in the function, and then f of b nothing but f of x, f of a nothing but f of 0. So here f dash of c we have to find. For that we need to find f of a and f of b. So here f of a is equals to f of 0 and e power 0 is equals to 1. So f of a value is 1. Then f of b nothing but f of x, that is equals to e power x. Then f of b is equals to e power x, and the values of a and b are 0 and x respectively. Then f dash of x is equals to f of b minus f of a by b minus a, and that equals to f of b nothing but f of x minus f of a is f of 0 divided by x minus 0, and then f of x value is e power x, that is and the next f of a value is 1, that is f of 0, and divided by x minus 0 is x. Then f dash of c is equals to, we got the value as e power x minus 1 by x. Then here f dash of c, f dash of x we got it as e power x, derivative of e power x is e power x, and then f dash of c nothing but we have to substitute c in the place of x, and that gives us e power c, and that equals to e power x minus 1 by x. So let it be as equation number 2, and we got this from equation number 1. Then here we have the condition as, we know that c lies somewhere in between 0 to x. So as c belongs to 0 to x, so c lies in between 0 to x. So we can write a condition as 0 is less than c and its c is less than x. So if we write it here, if we take this as 0 and it is as x, so c lies in between 0 to x, that states that c belongs to 0 to x. So here if we see 0 is less than c and c is less than x, so we have written the condition from here. Then 0 less than c and c is less than x. We have to bring this c into the form of e power x. So for that we are doing some changes here, just by taking exponential. When we take the exponential here, e power 0 and e power c, e power x, we are taking the powers to the exponential. Then e power 0 is 1 and it's less than e power c and less than e power x. Then here e power c value we got, we know that e power x minus 1 by x, so we got it from equation number 2. So write the value of e power c here, then that becomes 1 less than e power x minus 1 by x less than e power x. So in between we had to bring back to e power x, so we had to eliminate all this minus 1 and divided by 2. So when we multiply with 2, all these terms, x into 1 is x, and in the here it multiplies with x, e power x minus 1 into x by x less than e power x into x. Then here x will get cancelled, so we get it as x less than e power x minus 1 less than x into e power x. So when we add 1, so that minus 1 plus 1 becomes 0, so that we are adding 1 on to this all three terms, we get 1 plus x less than e power x minus 1 plus 1 less than x into e power x plus 1, and here 1 plus x is less than e power x, here minus 1 plus 1 becomes 0, so your less than e power x less than 1 plus x into e power x. So therefore we have bring back to the work condition and we have proved it, that is 1 plus x is less than e power x less than 1 plus x into e power x, hence proved. So in this way we will find out the f dash of c and the point c, and here we have the two conditions for the Lagrange's mean value theorem. First condition is the function should be continuous, and the second condition is the function should be differentiable.